In this section, we move from AI that answers to AI that acts. That changes the security model. We'll look at how to secure agents, APIs, production access, and workloads with controls that can allow, block, log, simulate, throttle, or require human approval. We've already built the foundation: governance, risk, responsible AI, and secure architecture for LLM and RAG systems. Now the focus shifts from model interaction to system action, where agents use tools, APIs, data, workflows, and production environments. With a traditional LLM, the main risk is often the output: an inaccurate answer, leaked information, or unsafe content. An agent expands that risk because it can act. It may send emails, update tickets, query databases, trigger deployments, or modify cloud resources. That means the security boundary must expand as well. We need identity, authorization, action limits, approvals, logging, monitoring, and recovery. The key question is no longer just what does it know? It is also what can it do? A secure agent should not have a direct path into enterprise systems. Its plans and tool requests need to pass through controlled mediation. A policy engine checks identity, permissions, context, and risk before anything runs. A tool gateway brokers approved calls to APIs, databases, and applications. Human approval handles sensitive actions, while audit logging records who requested what, why, and with which evidence. That separation turns agent autonomy into governed, traceable execution. Treat every agent as a first-class identity, not as a shared API key or hidden admin account. A user may approve a goal, but the agent still needs its own delegated permissions for each tool, dataset, and environment. This separation lets you enforce least privilege, rotate short-lived tokens, and revoke access quickly if behavior changes. The design question is simple: what can this agent do, for whom, with which data, and for how long? Agents should not decide what they are allowed to do from prompts alone. They need policy constraints that operate at runtime. A request may be safe for an IT admin, risky for an analyst, and forbidden for an external user. The decision should account for data sensitivity, environment, confidence, reversibility, and business impact. Good policy turns those signals into outcomes: allow, deny, require approval, simulate first, or rate limit. Policy as code makes those decisions consistent, testable, and auditable. Every AI tool call is a security boundary. The model may suggest an action, but the system must decide whether that action is allowed. Place a controlled gateway between the agent and real APIs. Check authorization, limit volume, validate inputs and outputs, and require approval for sensitive operations. Whenever possible, separate recommendation from execution with read-only, dry run, or approval-required modes. This keeps model creativity useful without turning it into uncontrolled system behavior. An agent recommendation is not permission to act. Start by treating the suggestion as untrusted. Then run it through policy checks and, when risk is meaningful, test it in a simulation or dry run. Before anything sensitive or irreversible happens, a human should see what will change, why it is needed, and what could go wrong. Only after approval should controlled execution proceed, followed by logging for accountability. Tool calls need checks on both sides of execution. Before the call runs, validate the request. Does it match the schema? Use an allowed action, target an approved resource, and satisfy business rules such as required approval. After the call completes, validate the response. Redact secrets, remove irrelevant bulk data, and block anything that looks like instructions to the model. These controls prevent tools from becoming a backdoor for unsafe actions or prompt injection. Workload isolation is layered containment. Experiments belong in sandboxes, not beside production systems. Public data should not share the same controls as regulated data. Standard inference should not sit in the same trust zone as autonomous or high-risk agents. The goal is to limit blast radius. If something fails, leaks, or behaves unexpectedly, it affects only its zone. Then stronger controls can be applied where risk, sensitivity, and business impact are highest. Shared GPUs change the security model because one physical accelerator may serve many teams, models, and datasets. Treat scheduling as a security control, not just a performance tool. Sensitive jobs need stronger isolation, trusted images, and approved placement. Telemetry should watch memory use, model loads, utilization spikes, and unusual job behavior. The goal is to prevent leakage, unauthorized execution, noisy neighbor risk, data movement, and model theft, while still using expensive GPU capacity efficiently. For agentic systems, logging is more than debugging. It is the evidence trail for trust. Each meaningful action should record who the agent was acting for, which tool and target system were used, what policy decision was made, whether approval was required, when it happened, and what resulted. Where risk justifies it, preserve the prompt, plan, tool response, and execution trace. Make these logs tamper-resistant and ready for SOC workflows. Operational control means an agent is never truly unattended. Imagine it receives an ambiguous request and starts preparing a bulk customer record update. Monitoring flags the action as high impact, pauses execution, and locks the relevant tools or credentials. A human reviews the pending changes, then approves them, rolls them back, or triggers compensating steps. If the pattern looks suspicious, escalation brings in security, legal, or operations, and the policy is updated afterwards. Agent control is best viewed as routing, not a simple yes or no gate. Each proposed action is scored by impact, reversibility, confidence, data sensitivity, and current context. If risk is low and rollback is easy, allow it and log it. If the action touches sensitive data, throttle, mask, and audit. If confidence is weak or impact is high, simulate first or require human review. If policy is unclear, block by default and escalate. iAgent security is enterprise security for systems that can act. Control identity, authorization, policy, and human override. Protect every API and tool with validation and approvals. Isolate workloads by sensitivity and criticality. Next, we extend this foundation into observability, telemetry, and SOC response.